The examples is taken from your textbook, exercise 2.5, page 41, number 4. You are given a quadratic equation and the quadratic has no roots. Define for A, B, C, and then find the discriminant D. Substitute A, B, C. And then because you are given the information that the quadratic has no roots, the characteristic of the discriminant is less than 0. So you need to solve for K. Number 6. Again, you are given a quadratic equation. And the quadratic equation has two distinct roots. First, define for A, B, C. And then find the discriminant. And then substitute for A, B, C. The B is 2k plus 6. And then because you are given the information that the quadratic has two distinct roots, the characteristic of the discriminant is greater than 0. Then solve for K. Number 8. This is the quadratic equation. And this quadratic equation has two equal roots. Two equal roots here means the quadratic has only one root. Define for A, B, C as usual, and then find the discriminant D. Be careful with the B. And then because of two equal roots or one root, the characteristic of the discriminant is D equals 0. And then solve for K. Now you have two values of K. Okay, do you understand these examples? Now, what if we apply the quadratic curve at straight line? Look at these three situations below. Situation 1, if you are given a line and a curve, and the line cuts the curve at two distinct points. Situation 2, same, you are given a line and a curve, and the line touches the curve at one point only. And situation 3, you are given a line and a curve, and the line doesn't cut the curve at all. The discriminant's characteristics can also be applied on those situations. Special case for D is greater than 0 and D is equal to 0. We combine into D is greater than or equal to 0. Use the special case of D if the information given on the question, real roots only or intersects only. Next, exercise 2.6, page 44, number 1. You are given a line and a curve. The line is the tangent to the curve. Do you remember how to solve the simultaneous equations between one linear and the other one non-linear equations? Yeah, we use substitution. Substitute the y from the linear into the y from the curve. Rearrange into your right-hand side is equal to 0. Collect the same terms and simplify. Now you see the quadratic equations, right? Define for A, B, C again. Because of the tangent, where the tangent means one point of intersection, the line touches the curve at one point. Do you remember? Use the characteristic of discriminant D is equal to 0. Find the D. Use the characteristic and solve for K. There are two values of K. Do you understand this type of questions? Let's see another example. Now, from number 4. Again, you are given a line and a curve. With the information, the line intersects or cuts the curve at two distinct points. Substitute the y from linear into the y from curve. make your right-hand side is equal to 0. Collect the same terms and simplify. You will see a quadratic equation defined for the value of a, b, c. And then because of the two distinct points, it means the characteristic of the discriminant is greater than 0, isn't it? Find the d. And then d is greater than 0. You will see a quadratic inequality. Do you remember how to solve it? Assume this is linear, find the two k's, and then sketch the graph, and then find the greater than 0. That's the answer. Do you understand now?